So before the word problem, okay, just quickly recap because later on we'll be using this technique, okay? So question 7a, right? Question 7a is an equation that has fraction. So take a look at how we turn it into general form, right? We multiply by common denominator, okay? We've done this several times. And then it turns into general form here. Once you get the general form, you can apply it to the formula, right? Solving the ABC. All right. So if the question does not ask you which method to use, and it has very difficult to factor, not able to factor, then you use the formula. So let's start from question 8 first. Okay. So let's have Evan, you read question 8 for us.
8.
Yeah.
A ball is thrown off a tall building. Its height, h meters, t seconds. After release is given by h equals negative 4.9 t squared plus 5t plus 40. How long does it take to hit the ground?
Okay, thank you. So here they give you a function, right? This is, instead of x and y, they have t and h, right? So that's why it becomes a word problem. T is the seconds after release. So you let the ball drop, right? And h is the height of the ball, right? So if you plug in the time, you can calculate the height of the ball at different time. So for example, if I sub in t equal to 0, right? If t equal to 0, then height will be, you need to sub into all the t, right? Negative 4.9 times 0 squared plus 5 times 0 plus 40, right? Anything times the 0 will be 0. So you will just end up with 40, right? So that means at the beginning, right? T equal to 0 means at the beginning. At the beginning, the height of the ball is 40 meters off the ground, okay? And then from there, it starts to drop, all right? So let's calculate one more height, all right? So after, let's say 1 second later, all right? So can all of you try it out? Okay, sub in 1 into the time. Okay, when you get the answer, please raise your hand. Put 1 into the t. You can use calculator. Okay, raise your hand if you found the answer. Not yet. Shouldn't take that long. I'm going to just type it into calculator. Okay, Angela, what do you have?
Negative 49 squared plus 45. Oh, sorry, negative 4.9 squared plus 45.
Yeah, what's that equal? The square only for the 1, okay? The square, you do not square the 4.9 as well, okay? Try again.
40.1.
40.1, like this.
I think so.
Do you think this answer makes sense?
I don't know.
Well, this answer means what happened to the ball after 1 second, right? So it used to be 40 meter, now it become 40.1. Do you think it makes sense?
No.
Why not? Is the height supposed to go up or down?
Down.
Because what's happening to the ball?
It's falling.
It's falling, yes. Okay, so the height should be smaller and smaller, right? Yeah, so it cannot be higher than before. At the beginning, it was 40 meter. After 1 second, it should become less, right? Or wait, or is it going, maybe it's going upwards, right? Okay, so how about Evan? What do you have?
I got 1.247. I think that's wrong.
Okay, how did you type it in? The square only for the 1.
Oh, I didn't type the square. Wait, I forgot about the square.
But square for the 1 is still 1, right? 1 square is still
Yeah.
1, doesn't change anything.
Yeah.
Okay, let's try
But
again.
I didn't write the 40.1 though.
4.1. Yeah, I think Angela was right? Because this one is 0.1 plus 40 is 40.1. So looks like, yeah, I thought it's just dropping it down, okay? So looks like it's throwing up and then falls down, okay? Let's try one more, all right? 2 seconds then, okay? So h equals to negative 4.9. You got to follow the order of operation, right? Square first, right? So raise your hand again once you got the answer for 2 seconds. Okay, can I have Ivy? What's your answer?
I got 30.4.
30.4. Okay, 30.4. How about Chris? What do you have? Huh? I can't hear you.
30.4.
30.4. Okay. All right. So 30.4. So looks like it's dropping down, right? So let's make a picture to show you what's going on here. So you have a building, right? So building here. All right, here's the ground. And then this guy is throwing the ball, right? At the beginning, it was 40 meter, right? So ball starts from here, 40 meter, and it will go up, right? Go up first, right? And then go down. Okay, so 1 second, right? This one is t equal to 0. This one is t equal to 1. Okay, and then t equal to 2 will be like 30.4 meters, so somewhere here, right? And then afterwards, maybe after another second or two, right, it will hit the ground. So t equal to 1 second, it will be, it was 40.1, right? So 40.1 is talking about all the way from the ground, and then 30.4 is as well going from the ground. So that's what it's talking about, all right? So now it asks us to find when, right? How long does it take to hit the ground? So what should we do now? Now you understand the question, right? But what do we need to do to answer the question? Yeah, Elaine?
Set height equals to 0.
Yeah, very good. Okay, so hit the ground means the h has to be 0. Okay, so you just need to sub it in. We are looking for time. You can write negative 4.9 t squared plus 5t plus 40. H is 0, so equal to 0. So this one you can see is a general form. Because it's already in general form and you have a decimal there, right? Difficult to factor, you just go straight to formula. Okay, so use formula. Quadratic formula. Right, so it's time to, if you haven't memorized the formula, okay, take a peek at your notes, find the formula and plug it in, okay? So T equals to, I'll let you try by yourself, fill in all the blanks. And if you found the answer, you should get 2 answers, okay? So once you get the 2 answers, leave them in decimal numbers. And let's round it to the nearest 10th. Okay, raise your hand when you have the answers. Your answer has to be more than 2 seconds, right? You can see from the picture, right? 2 seconds is still 30 meters above the ground. Is there anyone here doesn't know what to do with the formula, right? How to plug into formula? Let me know. Don't forget plus minus. One answer is using the plus, the other answer is using the minus. Okay, did anyone get the answer yet from the calculator? Okay, let's check the numbers in the brackets. Okay, see if you guys put the right number. Negative b plus minus b squared minus 4ac C over 2A. When you type into your calculator, make sure you have everything on top in bracket, right? Get the answer first, divided by everything at the bottom. Okay, let's check the number inside the square root first. Okay, Harry, can you tell us what you have inside the square root?
I didn't calculate it yet.
Okay, I'll wait for you. Let me know when you have it.
-25 minus 45.4 in the what's it called?
Square root?
Yeah, in the square root.
I think it's too small, okay? Be careful on the sign, right? Because there's a negative in here, right? Do you see a negative 4.9? That will make it, okay? So it will become 25 and then plus 4 times 4.9 times 40. Okay, try again.
Negative 500, no, 759.
No. Okay, can you tell me what's this part? What do you get here?
-784.
Yeah, 784, right? Okay, so if only those three numbers multiply, it's negative 784. So you need to do 25 minus, right? 5 squared is 25. 5 squared
Oh,
is
I see.
25 minus negative 784. What do you have?
759, negative 759.
25 minus negative 784.
Oh, 804.
No?
809.
Yes. Okay, and then over what? What's in the denominator?
Negative 9.8.
Yeah. Okay, and calculate each one. One answer using the plus, one answer using the minus. Okay, if you have the two answers, please raise your hand. This is taking too long, okay? Calculator should be an easy work. Yeah, it may sound easy, right? Because when you guys hold the calculator, you think everything become easy, but when you have negative numbers, you still need to think about what to put. Or if you have some calculator, it can show the what you typed in. Then you can double check, right? See if you typed in correctly. Keep your answer in rounded to the 10th, so one decimal place. Only one person got it. Marcus, do you have any questions?
No.
Then can you tell us one of your answer?
Still working on it.
Okay, are you doing the plus or the minus?
Huh?
Are you doing the plusing or the minusing one?
I haven't decided which one to do yet.
You do the plus first then. Okay. You know what I mean, plus?
No.
This one, look at the red. You do -5 plus square root of 809. And then you hit an equal sign, what do you get?
Negative. I got 23.4.
Yeah, okay, and then you divide it by the denominator. What do you have?
Negative 2.3.
Round it to the 10th.
Negative 2.4.
Negative 2.4. Okay, now you try again. Okay, find the one using the minus. Okay, so the green one, the minus. Okay, and tell me your final answer.
Negative 3.4.
No. Try one more time.
Hold on.
What do you get for the top?
3.4.
Positive, right?
Yeah.
Yeah, okay. Positive 3.4. How's the rest of you? Annie, Chris, Elaine, and Evan, Jao, and Waylon? Did you guys get the answer yet? Okay, so we have two answers here, right? But then this question cannot have two answers. Okay, these represent the time, right? Which answer should we keep then? Waylon?
I'm not sure.
Which answer do you think it makes sense with the picture?
3.4 because you can't have like negative time technically.
Yeah, okay, the time cannot be negative, right? And based on our picture, right, we can, the 3.4 makes more sense, right? After 3.4 seconds, then the ball will be on the ground. T equal 3.4. Okay, so we'll keep this one and we will reject. Okay, so at the end, you need to always write a sentence. So you can say it takes 3.4 seconds to hit the ground. Okay, so this is one of the many applications for quadratic formula. For anything storing the object, right, it's always quadratic. And then you can use the quadratic formula to solve the time, okay? So if no questions, let's look at another application. Okay, look at question 9. So this time, let's have, can I have Jenny? Can you read question 9 for us?
A small plane flies 630 kilometers against a 220 kilometer per hour headwind and returns with the same wind speed behind it. The entire trip takes 8 hours. What is the speed of the plane?
Okay, so does anyone have question about any word here, right? Any word that doesn't make sense or doesn't know what it means? What's the meaning of headwind? Braden, what's the meaning of headwind?
Going against it.
Okay, so would it speed up or slow down?
Slow down.
Yes, very good. Okay, so headwind, you can make a note, right? It will slow down. Make the airplane slow down. And then if you have the wind behind it, right, it will speed up. Speed up the airplane, okay? So the 20 kilometer per hour is the speed of the wind, okay? Not the speed of the plane. So the question wants us to find what is the speed of the plane. And it mentioned about the time here, right? This is the time. This thing, the 630 kilometer, this is the distance, right? And then he also mentioned about speed. We're looking for the speed. So something relates all three things together. Speed, time, and distance. Do you guys remember any formula that can connect them all? Any one of you learned it in physics, science, about these three things? Any formula? Jawan, do you remember? Any,
No.
anything connects them all? Anyone? Chris? Or do you remember? Elaine? Do you remember anything that has speed, time, and distance in a formula?
Yeah.
Yeah? Okay, what is it?
The distance over speed equals time.
Distance over speed equal time. Yeah, okay, that works. Thank you. Yeah, that's one of them. So in fact, there are three different formula depending on what you want to find. Okay, so a simple way to remember the formula is just think about the meaning of speed. Okay, when you see the speed limit in school zone, right? I think it's 30 kilometer per hour. Okay, let's say it's right on the side. Okay, let's say speed limit is 30 kilometer per hour. So that's telling you to, that means you can go 30 kilometer every hour. Okay. Yeah, so if you can go 30 kilometer every hour and then you travel for, let's say, 2 hours, then the distance, right? Every hour you can go 30 kilometers. So 2 hours, how far can you go? Harry? Harry, are you there?
Yes.
Yeah. How far can you go?
Um. Four.
What's that?
Uh. 460.
Huh? Where did you get that number from?
There's a at the top you wrote speed, and I think that's a 230.
Oh, that's an equal sign actually. Okay, 30
Oh.
kilometer per hour.
60 then.
Yes, okay, very good. 60 kilometer, okay? So from this idea, right, you can get a formula from it. Distance, you take the speed times the time, okay? Every hour you go 30, 2 hours, so you times it by 2. If it's 5 hours, you times it by 5, right? So we can put the formula into a triangle shape. Okay, and then we'll put distance on the top. Okay, distance equals to speed multiplied by time. Okay, so on the first one, if you want to find distance, It'll be speed times time. Okay, and then you can move around the formula, right? If you want to find time, let's say you want to find time, then you can divide by speed. Okay, for example, like here, if you want to find the time, then you take 60 divided by 30, right? Distance divided by speed. 60 divided by 30 is 2, right? So if you want to find time, it'll be distance over speed. Okay, and then if you want to find speed, which is Elaine's formula, so speed is distance over time. I think Elaine was saying the time, right? The formula for time. So those are the three, okay? So let's draw a line here. You need to know this before you begin, right? Otherwise, you have too many numbers here. All right, so can you raise your hand if you got everything down so far? Okay, Annie, Ivy, Jawan, have you copied everything down? You there, Jawan? Yeah, okay, good. Okay, so now you understand the three formulas, okay? Let's look at each of the numbers, okay? And because you have two trips, right? One is the slowing, right? The slower trip with the headwind. The other one is, we call that the tailwind, right? It will speed up. So one is going, one is returning. So we need to make a chart and to organize all the numbers, okay? But before we begin, we always need to write the let statement, okay? We'll need to write the let something be X, something that you want to find be X. So what should be the let statement this time? Angela, what's the let statement?
Let t equal time of the trip.
What's the question want us to find?
The speed of the plane.
Yes. Okay. So therefore, our let statement should be that. Okay, should be the speed of the plane. Otherwise, we lost our target, right? So we can say x be speed of the plane, right? So once you find the answer for x, then that's the answer for the question. That's the whole point of writing the let statement. So you keep your focus on. Right, so now you know the x is the speed of the plane, okay? Then let me draw a picture, okay? So you can better understand. So you have airplane, right? Here's airplane. You have the going, right? Going against the wind. So there's a wind blowing, right? And the airplane is flying at, right? This is airplane, fly at x kilometer per hour. And then the wind, okay, wind, I'll use different color. Wind is 20 per hour, kilometer per hour. Okay, and then you have this is the going, right? And then when the airplane returns, right? The wind doesn't change direction, okay? Then it becomes the tailwind, right? Wind blow behind it. So this is still the wind. Okay, and then the airplane will be going the airplane, of course, it will change direction. It will be going this way, still by x. So one is going, one is returning. And then we have the distance, right? The distance of flying is 630. That's starting from going to the destination and then return, right? The distance apart, this is 630 kilometer. Okay, so this way, some of you may be learning better with visuals, right? With pictures. That's why I draw the pictures. So let's put them into a chart now. Okay, we are going to use the first one, the first relationship, the blue one, speed times distance. Okay, so we can write it horizontally, speed, time, and distance. And then on the left side, you have the going trip, right? This is the going. And then you have the return. Okay, let's talk about the going. What will be the speed of going, right? What should we fill inside the box? This one, what do we need to put inside there? If the airplane itself, it can fly at X km/h, but it's going against a wind of 20. What will be the actual speed of going then? Anyone?
$20?
20? Well, 20 is the wind. The wind, right? Only the wind, not the airplane, right? So let's say if the airplane can go at 200 km/h, even if there's no wind, right? It can still fly, right? It doesn't need the wind to fly, right? Because it has engines, right? So if the airplane can go at 200 km/h, and if there's a wind of 20, what will be the actual speed then?
Would it be X minus 20?
Yes, okay. So you want to make it slow down. Very good, Colin, right? So if for the example I mentioned, if it's going at 200, because of the wind, it will slow down by 20. So it will actually be going at 180, right? So you got to do subtraction, okay? So if the speed is, for the going, you need to take the airplane and make it slower by 20. Okay, because it's slowing down due to the headwind. What about returning then? Evan, what do you think? How do we fill out the returning speed?
I'm not really quite sure.
Do you understand why we did x minus 20?
Not really.
Okay, do you know why going is slower?
Is it because there's like wind? Is there wind going
Going where?
like at the front of it? Like
Yeah, so it's like someone pushing you, right?
yeah.
Yeah, so you got to slow down. Even if you try to get ahead, so you slow down. So when you slow down, you have to do subtraction to make it smaller. Okay, Evan, keep your mic on, please.
All right.
Yeah, okay. So suppose you are going at 100, but then your wind is blowing at 20, so you'll become going at what?
80.
80, right? So now let's say you turn around, you are flying with the wind. Then how fast will you be going?
120.
Yeah. So now for the picture, okay, back to the question. Now, what do you think we should put inside the return speed?
X plus 20.
Yes. Okay, now you got it. Okay. So that's the reason for adding and subtracting, okay? To make it speed up or slow down if there's a wind, all right? Now, next thing is the time and distance, right? We have the number for the time is 8 hours, right? And then the distance is 630. Which one can we fill in? We have 4 blanks here, right? Which one can we fill in? Anyone wants to try? Can we fill in the time or the distance? Which one do we know?
The distance.
The distance, okay, so 630 for which one? The going or the return?
Both.
Both, very good, okay? They both travel the same distance, okay? So let's fill that in. 630. Now for the 8 hours, okay? The 8 hour is for the entire trip, okay? I hope you caught that, right? Entire trip means going and return together. So that's why the 8 hours, I cannot put in 8. Then that will be wrong, right? It doesn't match the what it's saying in the question. So the time is a mystery now. Okay, so I'd like you to circle that. This is the last column. So when you do a question like this, you will always be able to fill up 2 columns first and have the last one missing. And to get the last one, you look at the formula on the top, the one that has the time, right? The one I put a star beside it, the time. So time can be found by taking distance divided by speed. So you go to the table, okay? Distance for going is 630. Divide by the speed is x minus 20. So that will be the time for going. So what about the time for return? What do we put inside then? Waylon, what do we put inside?
Can you repeat that again? I kind of lagged out.
You understand how we get the 630 over x minus
I
20?
understand.
You got that part? Okay, so now my question is, what about for returning? Returning, what's the time?
630 divided by x plus 20.
Yeah, very good. So now we have the time for going and the time for returning, and it tells us together the entire trip is 8 hours. So together we add them up, right? Going time plus the returning time is 8. So there is our equation. Okay, so once you get to here, right, this is your step 2, right? You get the equation. Step 1, you write the last statement. Step 2 is the equation. Once you get the equation, then this equation looks like question 7a, right? Where you need to multiply by common denominator, get the general form, and then plug into the formula, okay? So that's the whole idea, right? Before we learn first, now you need to know how to apply it to word problem. But then for word problem, you need to figure out the equation by yourself. Okay, you can see the big picture. So after this, right, you need to solve. Solve for x, and then when you get the answer for x, then that will be the speed of the plane. So this is a standard example of speed, time, and distance problem, okay? And then of course the story can change, right? Instead of plane, I can change that to running, right? Anything that, or car, right? I can change that to car. Even the car will be affected by the wind, right? Or boat, right? A boat in the river, swimming in the river as well, right? So instead of wind, I can have water. Okay, so things question can change, but the idea behind it, how to do it, is the same. Okay, you still do the table and then make the equation. Okay, do you have any questions? If you don't have questions about this one, can you raise your hand? Okay, raise your hand if you understand everything for this one. Ask me now if there's any part that's not clear. Okay, so because the next one will be on your own, okay? So question 10, I would like you to do step 1 and 2, okay? Get the equation by yourself. Okay, so you guys try it. Question 10. So this one is, okay, swimming. Okay, so similar. Instead of airplane, we have Brian. So please, let's have Elaine, can you read the question for us?
Brian decides to start training for swimming in the river. The current in the river is 4 kilometers per hour. If he swims upstream 2 kilometers, then back downstream to where he started in 3 hours, what is his swimming speed?
Okay, very good. Okay, so as you can see, right, instead of the airplane, we have swimming Brian, right? Instead of the wind, we have the current. Current means the water flow. And it goes up, right? Think about, is it going faster or slower when you go up, right? Back down, right? Downstream, would it go faster or slower? Okay, logically. And it takes 3 hours to make the round trip. So please try it by yourself now, right? Make a table first. Don't forget to start with the let. And then make a table. Okay, and then write an equation. So once you got the equation, you can raise your hand and then we'll check the equations together. This one we are all going to solve it, okay, to the end. But we need to make sure the equation is correct, okay? We have the going upstream, right? And the going down.
Can you go back to the notes for question 9?
Okay. Yeah, make sure you copy down a good notes, okay, for this one. Yeah, it's okay, Evan. Okay, please raise your hand when you got the equation. If you're 100% sure your equation is good, then you can move on, okay? Do the solving. If you want to double check with everyone else, then you wait for us, okay? Your x should be the swimming speed. Okay, swimming speed. Just like the airplane speed. Anyone has trouble getting the equation or filling up the table? Okay, let's check the table first. Okay, only 4 people finished the equation so far. Anyone else? Jiawen, do you have the table?
Not yet.
Okay, any part that's filled in? Do you have the speed?
Right, I have the speed.
Okay, what do you have under the speed? Upstream,
Uh,
you have,
x minus 4.
okay? And down,
And for downstream, I got x plus 4.
yeah, very good. Okay, when you are going up, it will be slower. Slower means subtracting, okay? Okay, very good. How about Ivy? Did you complete the table yet?
Nope.
Do you have the same speed?
Yes.
Okay. What other ones have you filled in yet? Distance.
I think
we have these numbers, right? The 3 hours, the 2 kilometer, the 4 kilometer per hour. Which one can we put?
3 hours
3 hours, okay. Where do we put the 3 hours?
for time.
Which time? The up or down?
Up.
For up, okay. Does it tell you that it takes 3 hours to go upstream?
Wait, and then back downstream to where is
Look at the question, right? Does it tell you that it takes 3 hours to go upstream?
I don't think so.
Okay, what does it say? What's the 3 hours? What do they mean? It's 3 hours for,
3
yeah.
hours.
What's the 3 hours for?
The down.
Only the down? Right, you look at this sentence, let me highlight it, right? If he swims upstream and back downstream in 3 hours. So 3 hours, is it for up or down? Or for both?
Both.
For both, right? Yeah, okay. So I cannot fill in the 3 hours in any of them. Okay?
Okay.
So what should we fill in then? What's the other number we can fill in?
2.
Yeah, 2 kilometer. Where do we put that?
It's the distance.
Yeah, it's the distance. Okay. Here he swims upstream 2 kilometers. So this one is clearly for the going up. And then back downstream, right? Because it says back down, back. Back means back to where he started, right? To where he started, he mentioned that, right? So it's the same distance going down.
Oh.
Make sense? Okay. So he goes up 2 kilometers, swings back down another 2 kilometers. That's why he can get back to where he started. Okay, so last column, the time. Okay, Brandon, how do we get the time then?
I think it's 2 divided by x minus 4.
And the other one?
2 divided by x plus 4.
Yeah, okay, so the time is you take the distance for each direction, divide by the speed of each direction. That should be a 4. Okay, so the equation should be what? Marcus, what will be the equation then?
It would be 2 over x minus 4 plus x 2 over x plus 4 equals to 2. Oh no, it's nothing. I don't know what it equal to. Oh wait. 3. Would it be 3?
Yeah, the time, right? Entire time. The first part is the time for going up. This one is the time for going down. Together is the round trip. It takes 3 hours. Okay, so let's start solving, okay? So solve this equation. First, you got to, right, follow what you did before. Right, when you get an equation like this, you need to multiply by common denominator, turn it into general form. Okay, we've done this many times now, right? So what do we need to multiply by to get rid of the denominator? Okay, what do we need to multiply with? Any, are you there?
Yeah.
Yeah, okay. So how do we get rid of denominator?
You multiply everything by the common denominator.
Which is?
X squared minus 16.
Yeah, okay, good. You expanded it. Okay, I'll keep them separate, okay? X minus 4 and X plus 4. Right, so everyone please try that and solve for X. Okay, you can follow the steps in question 7a, right? Similar. Once you get to general form, plug into the quadratic formula. And for this one, once again, when you get the answer, one of them you need to reject, okay? Because you cannot have two different swimming speed, right? And that won't make sense. So you will see one of them is clearly not acceptable. So you can raise your hand once you found the answer, okay? Okay, Harry, what's your answer?
My general form,
Sure, okay, you have the general form. What is it?
3x squared plus 4x minus 16 equals 0.
Okay. Do you have the final answer from there or not yet?
No, yeah.
Okay, you just want to check general form. Yeah?
Yeah.
Okay, Colin, how about you? What's your general form?
What is it? I got negative 3x squared plus 4x minus, plus 48 equals 0.
Okay, so there's a difference in general form. That's important. Anyone else got a general form that's different or the same? Okay, tell us.
My I got something similar, but instead I got 3x squared minus 4x minus 48.
Okay. Oh, so the signs different, right?
Oh,
Okay. Anyone else? Anyone confirm with any of the three there?
I also
Mhm.
got 3x squared minus 4x minus 48.
So this one, okay, let's get one more and see if there's anyone else get the same one, just to be sure. Anyone else? So far, this one has two people.
Wait, for my thing, it's plus 4x.
Plus 4x.
Yeah.
Is that, and it's still keeping negative?
Yeah.
Negative 3x squared. Okay. Then yours will be the same as the bottom one then, right? It's just on the other side. Yeah, so column and right, the two circle one, they are the same. Okay, it's just placed on different side. So let's check. Okay, so far it feels like those two. So if I expand it, okay, I'm gonna show the step. Okay, if you got the same general form, you can move on. Okay, continue to get the formula, use the formula. When you multiply with the first fraction, x minus 4 will be gone. Okay, so double check with your step, see what you missed. And then with the second fraction, it will be 2 times x minus 4. And then on the right side, nothing canceled out. Okay, so any questions so far? And then you expand everything, so that will give you 2x plus 8, 2x minus 8, and then 3x squared minus, that will be minus 16 minus 48. Okay, so you can move everything to the left, then that will give you the first general form. If you move everything to the right, then it will give you the second general form. Okay, so it doesn't matter which one. Okay, I'm gonna use the one that's moving everything to the right. Okay, so I have no negative at the front. Okay, but they are the same. Either way will give you the same answer at the end. So I move everything to the right, but then I put the answer on the left. Okay, and then plug into formula. Okay, please find the two answers and raise your hand, okay? Once you got the two answers from your calculator. There will be decimals, so please round it to the nearest tenth. Okay, Marcus, can you tell us what to put inside the formula in the brackets?
Negative, in the first bracket, it's 4.
Negative 4.
Negative 4. And then it's bracket in the under the root, it's bracket minus 4 bracket squared minus 4 bracket 3 bracket, and then in the next one it's negative 48.
Yep, very good.
Bottom one is just 3.
Yep, 2 times 3. Okay, so have you got the two answers yet?
Not yet.
Okay. You guys, please raise your hand once you found the two answers. One answer using the plus, the other answer using the minus. And then once you get the two answer, think about which one should we keep, okay? Which one should reject? Okay, Angela, have you got one of them?
No, I messed something up in the middle, so I'm restarting.
Okay. Jenny, how about you? Do you have one of the answer?
I'm still working on it.
Okay, which one are you working on, the plus or the minus?
I'm doing the plus one.
Okay, so I'll let you answer the plus one. Chris, do you have the minus answer?
I'm gonna double check my answer first.
Okay, okay. Okay, Waylon, how about you? Do you have the answer that's negative?
I'm still working on it.
If anyone has trouble using the calculator, let me know, okay? And I can check one by one and find out which part you got stuck on, okay? So Jenny, have you got it yet, the positive?
Hold on. I messed it up when I did it earlier, so I'm trying to correct my answer right now.
Okay. All right, so Waylon, you got it?
Yeah.
Okay, what's your answer for the negative?
Negative 3.3. I'm not sure if that's right.
Round it to the 10th. Did you round it to the 10th?
Okay. Yeah. Yeah, I rounded to the 10th.
Negative 3 point, I think it should be negative 3.4 if you round it to the 10th. Okay, you can double check. Okay, Ivy, how about you? What's the other answer?
I got 4.7.
4.7. Okay, 4.7. Thank you. Jenny, do you have the 4.7 or?
Yeah, I got 4.7 as well.
Okay, okay. Jiawen, how about you? 4.7?
Yeah, I got 4.7.
All right. So we need to reject the negative, right? Because you cannot have like a swimming speed of negative number, okay? And also the swimming speed cannot be like smaller than for the current, right? Otherwise, you will be swimming backwards, right? And the current is faster than your swimming, right? So you will never reach your destination. So finally, right, we need to write a simple sentence. And you can just say his swimming speed, right? Or he swims at 4.7 kilometer per hour. Right, so I hope you understand how to do the speed kind of questions, okay? Word problems. It's always like this, setting it up with the table, okay? And okay, so let's have a break. We'll just have 10 minutes break and I'll see you at 3:10, okay?